Welcome to another day on the Journey Chez Chem. As is normal for us, there are 2 questions for you to do in the warm-up. Please do them to the best of your ability, and I will see you soon. The question in number 1 asks for us to determine the oxidation number or the charge of the underlined element. Well, the first element here is chlorine. Now, it is important to remove the polyatomic ion from the compound. It's much easier and the numbers are much smaller. So we're going to look at perchlorate, and I know that you're learning those polyatomic ions. We're going to set the whole charge equal to the overall charge of this polyatomic ion. This polyatomic ion is like an automobile that has 4 tires and 1 steering wheel, and the whole thing is red. So we have to put the charge of the overall polyatomic ion as what we're setting it equal to. Oxygen is -2. There are 4 of them. That gives me a -8. My unknown is the chlorine, and therefore chlorine is +7. Now, yesterday we learned our diatomic molecules: iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. And a nice little sentence to remember that: I brought clay for our new house. Those are the diatomic molecules. So this molecule is actually a compound, and its overall charge, like all compounds, is 0. Therefore, its charge is 0. So that's a little bit of an introduction of a new idea. Now, the old way, we're going back to it. Oxygen in the negative position is -2. There are 2 nitrogens, and compounds are 0. So in this case, nitrogen is +1. We're now looking for nickel. So I know my polyatomic ions, and sulfate has a -2 charge. And compounds are always 0. That never changes. So nickel must be +2. Now again, we're with the polyatomic ions. I take the polyatomic ion out of the compound, and it has an overall charge of -3. Now, I could do it inside this compound, but the numbers become a lot more complicated, and I would just rather do it easier way. I know that the overall charge of phosphite is -3, so I set it equal to -3. Oxygen's charge is -2. Times 3 is -6. Therefore, phosphorus must be +3. Now in F, we are also looking for the charge of an element in a polyatomic ion. So I will remove the nitrate from the compound and set it equal to its overall charge. Oxygen's charge is -2. Times 3 is -6. Therefore, nitrogen in this case must be +5. And that's how you find the oxidation numbers of some of the elements. In number 2, you must write the charge in the Roman numeral above the word. That is extremely helpful. Sulfate has a -2 charge, and compounds must be 0, so it is just CuSO4. I only need 1 of each, because it's already +2 and -2 is equal to 0. Roman numeral 5 is telling me that the nitrogen has a +5 charge, and oxygen, when it follows its periodic position, is -2. The common multiple is 10, so N2O5. By multiplying the nitrogen by 2, I get +10. By multiplying the oxygen by 5, I get -10, and +10 and -10 is 0. Sodium is an alkali metal, so it's always +1. That's why I don't need a Roman numeral. Dichromate is a polyatomic ion that is -2. So the formula must bring the compound to 0. So +2 and -2 is equal to 0. And that's how you do those three. Now the next ones, we're going in the opposite direction. And the first question I ask myself, is lead an alkali metal? No. Is lead an alkaline earth metal? No. Is it one of the silly six? No. So I must have to have a Roman numeral. I look at the negative position. It is -2. I want to know lead, and compounds are always 0. So this has to be lead, Roman numeral 2, chromate. Same thing in the next one. Iron is not in group 1A or 2A or one of the silly six, so I must have a Roman numeral. Well, this polyatomic ion, that's a challenging one. It's oxalate. Well, oxalate has a -2 charge. And there's only one iron, and compounds must be 0. So it's iron, Roman numeral 2, oxalate. That's an interesting one. Now, aluminum is one of the silly six, and it's always +3. So this is just aluminum chlorate. It's not trichlorate, it's just aluminum chlorate. Tri is only used for nonmetals and nonmetals, and this is a metal with a polyatomic ion. So its name is aluminum chlorate. Every day we need to learn a little something new, so let's try something today. We need to make a distinction between a molecule and a formula unit. We refer to everything as molecules, and that's fine, but we need to understand that there is a difference in their electrons and what's going on between the elements. In a formula unit, we have things like sodium chloride. Sodium has 1 dot and chlorine has 7. So what chlorine wants to do is steal this 1 electron away. And then sodium doesn't have any electrons in its outermost energy level. However, we learned before that sodium was atomic number 11. So its electron configuration is this. And when it loses this 1 electron, then this configuration looks like neon, which is a noble gas. So sodium is perfectly happy to lose that 1 electron, and chlorine gains an electron to have a complete octet, and so they're both happy. It's a win-win situation. But what happened here is that we transfer electrons, and we call this an ionic bond. And we have this happen when we have metals with nonmetals. We have ionic bonds. Now, in the case of a molecule, we have things like water. Well, oxygen has 6 electrons, 6 dots, 6 valence electrons. Hydrogen has 1. So in this case, hydrogen can get its duet. So it has the electron configuration of helium, which is a noble gas, and makes it happy. And oxygen gets an octet. So all the elements are happy like that. And so in order to do this, they must share their electrons. So they share electrons. They are covalently bonded. And that's the 2 distinctions. These are the 2 major types of compounds that we have. They're either formula units or molecules. They either share electrons or they transfer electrons. And that's the way they work. Now, when we're looking at a formula, for example, one of the formulas that we had in the warm-up was SN3PO32. When we look at this formula unit or molecule, technically this would be a formula unit because we have a metal with a polyatomic ion. So that would be a formula unit. When we look at this, we see this subscript. This number 3 is a subscript. We have 3 atoms of tin, 2 atoms of phosphorus, and 6 atoms of oxygen. Now, if I put a big number in the front, like a 3, that is called a coefficient. The coefficient is referring to the whole whole compound. Therefore, I have 9 tin atoms. I have 2 phosphorus in the compound, times 3 is 6 atoms of phosphorus. I have 6 atoms of oxygen and 3 of these molecules, giving me a total of 18 atoms of oxygen. Because these compounds are like things in a box. You can't change what's in the box, but I have 3 boxes. So I would have 18 of those oxygen atoms in those 3 boxes. That's what I want to talk to you about today. That was some fun, and we learn every day. And I thank you for being here, and we'll see you tomorrow.